All right, so we're looking at this factoring remediation worksheet. And it says as a reminder, for all types of factoring, start with the GCF and then make sure you don't lose it, is sort of what that's reminding you of. And so why this is called a remediation worksheet is we're breaking down each concept specifically. So let's go ahead and dig in. Was there a GCF for number one? Yes. So it should have been a 5, nope, not a 5x, 3x. Agreed, 3x? All right, so let's take that 3x out. Now, how do I know I'm factoring by grouping? Because I have 4 terms. So that's what I want to remember. When I have 4 terms, that should be my tip off that I'm probably factoring by grouping. And when I go to group it, I'm using these brackets because the grouping is going to be in parentheses with a plus sign in the middle. So we want to remember that form. So let's see what's left here. We have a 5x to the third minus 25x squared plus 4x minus 15. No, not 15. All right, there we've got it. So when I come in to group it, I'm going to go ahead and do this in a black pen here. When I come in to group it, I want to group those first 2 plus sign, group those second 2, and I'll leave that 3x out as part of it. I like the brackets to separate it, and then I'm really just going to focus on this chunk right here. So what comes out of here is a 5x squared. What's left is x minus 5. Keep my plus sign in the middle, and what comes out of here is a 4, and I'm left with x minus 5 when I divide that out. So I have my common factor of 3x from the beginning, but if I look inside here at these 2 terms, they both have the x minus 5. So that's a little more abstract, but that is your common factor that is being pulled out, just like we took out the 5x squared, and this was what's left. We pulled this out, and what's left is 5x squared plus 4. Now, before we move on to the next problem, I need you guys to double check this. That's one of the questions, like, well, how do you know if it keeps factoring? Because we look at it. There's no GCF left in here. There's no GCF left in here. There is a higher power on x, but it doesn't factor down as a difference of squares. So I am done. I'm going to go ahead and make that my final answer. All right, so looking at number 2, go ahead. Let's look for a GCF. Those are some pretty big numbers, which can be overwhelming. I'm going to focus on the smaller 2. So 49 does not work. 7's the only other option, and that does work. So you need to use your calculator and double check that. So let's go ahead and take out that 7. How about any variables? There's a lot of variables going on. Any variables you can take out? Mm-mm. All right, so just the 7. I would check on my calculator to make sure I have the right numbers. 64 UV plus 56 UX squared plus 8XV plus 7x to the third. Okay, so now that I've got that, we're going to group it. There's no reason to rearrange it unless you try to group it and it doesn't pair up. So I don't rearrange unless I'm forced to. Keep my 7 out front. I don't want to lose that. What do the 64 and 56 have in common? Yeah, they have an 8 and you said a U? All right, so 8V plus 7x squared. Okay, bring down that plus sign. These don't have a number in common, but they do have an x in common. So 8V, I need to make sure my V looks like a V, plus 7x to the second. Okay, so there we have it. If we look at these 2 pieces, they both have the 8V plus 7x squared. So that comes out, and you're left with 8U plus x. So take a minute, double check yourself. Any common factors, variables, higher powers that need broken down, and we are set. Okay, I'm actually going to skip numbers 3 and 4 and come back to them. So numbers 3 and 4 said they have more than one step, and I'd like to come back to those because I think we need to brush up before we do those. So let's jump down to 5 and 6. Now, I have on here reverse FOIL easier. Do you remember what makes the reverse FOIL easier? Yep, when a is 1, when the coefficient of the square term is 1. Now, someone's looking at number 6 saying, well, that's not a 1. You're right, it's not, but it has a GCF of 2. So the idea is a is 1, And why does that make it easier? When A is 1, factors of C will add to B. All right, so what am I talking about? Factors of C will add to B? Well, I'm talking about that whole idea of ax squared plus bx plus c. When A is 1, the factors of C will add up to B. Okay? So now that we've got that, I'm going to drop right into reverse FOIL. I still need to check it, but I don't have to work too hard. So my first term, P times P. My last term, I was thinking of 7 and 3. 7 times 3 is 21, but I needed to add up to what? What's the middle? What's B? Negative 10. So I need to change my signs, right? A negative times a negative is a positive 21, adds up to negative 10. So drop those in. And then let's just double check it. It's a good habit to be in. I've got my P squared. I've got my 21. The outside is negative 3P, negative 7P for the inside. There is my outer and inner that I checked. All right, so that shouldn't be too bad. Let's look at number 6. If, and I think a lot of us were doing this, we were just jumping in and factoring, which is more work because A is not 1, and then it's more work because if you don't catch it at the end, you just got it wrong. So if you take the GCF out first, I think that's going to save us a lot of headache. So I've got x squared plus 6x minus 7. All right, now that I've got that out, you see that trinomial, that quadratic trinomial. We're going to jump right into reverse FOIL because A is 1. So take a second and get that set. What are my factors of negative 7? Well, negative 7 and 1. Now that doesn't work, right? Negative 7 and 1 does not add up to 6. What do I need? Positive 7, negative 1. So wrong sign, change signs. Right number, wrong sign. So double check yourself. We have the negative 7. The outside and inside adds up to our 6x. Okay, now, this is where it gets harder. This is where I have to break out my pencil because now A is not 1. So the next set is your reverse FOIL and it's harder. Why is it harder? Because A is not 1. The factors of negative 7 will not add up to 5. Now, I think this is a great trial and error problem, but if you like busting B or, factoring by grouping, you can always do that. You guys have that half sheet that we talked about that has the steps for busting B, as well as your perfect squares as a nice reference. So that might be something that you want to use as you're studying. Okay, I'm going to go ahead and just do trial and error. But again, if you want to, we can go over a busting B one. So here we go. I'm going to drop right to reverse FOIL, but I'm not 100% what numbers are going to work. I know my only options are 2 and 1, so that I'm pretty confident with. So I'll put that in pen. My only options for negative 7 are negative 7 and 1, or 7 and negative 1. And the reason I want to jump over to some pencil now is I don't know which one fits where, okay? So if I put the negative 7 here and the positive 1 here, I need to check 100%, do I get a positive 5? So I know the first and the last work, that's not my concern. But if I multiply the outside, I get 2m, and I multiply the inside, I get negative 7m. Well, that adds up to negative 5. What did I want? Yeah, I want a positive 5. So I got the right number, wrong sign, so switch signs. So that would be a negative 2 and a positive 7, and there's my positive 5m. So that's a great trial and error. It took me one try with flipping signs. Okay, look at number 8. Is there a GCF there? There is something that I want to fix. Do you see it? What would make it easier? Let's take that negative out. You don't have to do that, but my brain functions better if I don't have to worry about that till later. So I'm going to take out a negative 1, and I'm left with all the signs flipping. So double check that you change your signs. I think it just works and helps us. So I'm going to leave that negative sign out there, or negative 1. And my options for 10 are 5 and 2 or 10 and 1. And I want to list both options so I don't forget them. my options for -6, -2 and 3, -6 and 1. And again, we can adjust our negative signs at any point. So I'm going to put in the 5x and the 2x because that's what I have first. And then when I go to put in the -2 and 3, I can save myself some time. Where should I not put that -2? Do you remember this idea? Don't put it with this 2x because I shouldn't have any common factors, right? So that's going to cut down on my trial and error. There should never be common factors if there was no GCF. So I'll put the -2 here and the +3 here. Now I'm trying to get this -7. I want to make sure I don't go back up there. I want this guy. So the outside is a +15x and the inside is a -4. Okay, so that definitely does not work. Before I throw it out, I'm going to flip the numbers, not worried about signs. And that gives me a +10 and a -6. So that, again, does not work. So I'm going to throw out the -2 and 3. I'm going to come back and try again. Oh, I said I didn't need to do that, right? Because the 2's. So if I forgot, it still doesn't work, right? Even though I told you not to worry about it. I'm going to put in the 6 and the 1. I'm going to put the 6 here. It cannot fit here. This would be a +5x, and this would be a -12x. And there it is. We got it, right? -7x. Now, if that didn't work, I would have gone back and started again with 10 and 1. And the 10, I would not pair with the 2 or the 6. All right, so we've got it. We can move on. Now, if you didn't factor out the negative sign, you might have had it as a -5x plus 12, or had this and -2x minus 1. Just depends on how it fell. All right, how about number 9? If I jump in, I'm making my life a lot harder, aren't I? So what should I do before I reverse FOIL and trial and error or bust B? Is there a GCF? Yeah, I mean 5, right? I'd love to take out a 20 or a 10, but I can't. But a 5 comes out, so what's left? 4a squared, +29a, and a +45. Okay, so if you're doing busting B and you like that, that's fine. You're going to take 4 times 45 and find those numbers that add up to 29. If I'm doing reverse FOIL, I am not worried about getting that 29 until I start trying numbers. So if I'm busting B, I multiply these two and then I find the factors that add up to 29. But if I'm doing reverse FOIL trial and error, I am going to focus on my factors like this. And again, I think it's good to list every option. Now, anytime I have a perfect square, I'm going to start with that double factor. So I'm going to start with my 2a and 2a, and I want all positives. And why I like starting with the double factor is it's a one and done. I don't have to flip. So here's 10a and 18a, close but not it, right? So I'm going to throw that out, and I'm going to try 15 and 3, which is going to be too big. I already know it's too big because they're both positives. There's 6 and there's already 30. So I'm going to throw that out. And can we see that 45 would really be too big? Because that would give you 2a and 90a. So guys, I now need to throw out the 2's and come back and try 4 and 1. All right, so a lot of erasing on this one. All right, so put in a 4 and a 1. Order does not matter. And then let's go back to our 9 and our 5. And there it is. There's the 20a, and there is the 9a. So it took me the 4 tries to get there. Unfortunately, it could have taken me more if I didn't have that number set. So that is my answer. All right, what do you see? What do you want to do with 10? Those are some pretty big numbers. Anything we can do to knock them down? GCF of? I don't want just a 4. What else? Can I take out a negative? See how that first term's negative? I think 4 is it, though. Do we agree on that? Okay. So take out that -4. What's left? 10n squared, what, 20? Yeah, 27n. I took out the negative, so change your signs, and a -81. Anytime you're messing with the negative sign, I say double check yourself. Okay, should we stick with trial and error? Does anyone want me to do a busting bee? Your call. Okay, I'll stick with trial and error, but you could use busting bee on any of these. So if I'm doing this 5 and 2, 10 and 1, negative 9 and 9, negative 27 and 1, or 3, sorry, and then 81 and 1. But I do need that negative sign. All right, let's start with the 5 and the 2. And let's do the double digits because that's a pretty quick check. So when I go to do this, I get what? 45n and negative 18n, which is good news because I got 27n. What did I want? I wanted a negative. So right number, wrong sign, what do? Flip the signs. Done. Problem solved. Now I have a negative 45, a positive 18. There's my negative 27. So that was a nice one and done. If I would have picked something different, I would have had to try some more things. Okay, what makes a difference of squares stand out? What should make it stand out? Because these are the next set, difference of squares. Oh, sure. All right, so what makes that difference of squares stand out? What should tell you when it's all mixed together, it could be a difference of squares? There's no middle term. There's only two terms there. The difference of squares is that idea of the a squared minus b squared. And I know I'm throwing in the a and b, but it's the idea that you have the a squared, like an ax squared, plus 0x and a minus c. And this isn't real official because the a would have to be a perfect square with the x squared, and c would have to be a negative perfect square. But the idea is the middle term is negative. And this factors down to be a plus b and an a minus b. That's where you get the a squared. That's the negative b. And because you have one positive and negative, the outside is a negative ab and the inside is positive. And that's why it cancels out to that 0 in the middle. Okay? So if you look at this and you have a list of perfect squares on a note card, or you're really good and you know them because you know your times tables, which is amazing, I should recognize that 4 and 9 are perfect squares. And it literally is a difference of squares. Has to be a minus sign. So I'm really doing reverse FOIL trial and error. I want to make sure it works. So it'd be a 2b times 2b. Isn't that what we always do, is do the double digits first? And then I'm going to do a negative and a positive 3. There's other options, but they have to be the same numbers to make it cancel. So 1 plus 3, 1 minus 3. So there's your 4b squared. There's your negative 9. And just to remind you, when we do the outside, we get a negative 6b, and the inside is a positive 6b. And that's why it cancels out and leaves us that 0 middle term. All right, so that's it. So look at the next one. There's only 2 terms, okay? Sometimes it's hard to tell it's missing the middle, but the middle term would be an xy. There's only 2 terms, but they're not perfect squares. Do you agree? What about a GCF? What would that be? Well, they both end in 5, right? So I'm going to try 5, see if I can go higher. Take out a 5, I'm left with 25x squared minus 9y squared. Okay, now I have a difference of squares. See how each term is squared? So go ahead and break that down. Jump right into reverse FOIL. 5x and 5x. It's not just a plus and minus 3. We need a y on it. So plus 3y minus 3y. So first and last, give me that. The outside is negative 15xy. The inside is positive 15xy. That's why they cancel out. Has to be a difference. All right, last concept group is on the back, and that is your perfect squares. So perfect squares don't stand out as easily because they're 3 terms. They're trinomials. Your perfect squares look just like all of these problems. You know, look at these, 6 problems here. They all look like 3 terms. So anytime I see this, the first thing I'm doing is obviously looking for a GCF. The next thing I'm looking at is, well, this is one of the easier ones because A is 1. Agreed? But anytime we had a perfect square, didn't I always tell you to try that double digit first? That's what should stick out. Now I have to make sure that it works. So I'm going to go ahead and try it. M times M, factors of 5 that add up to 10. Absolutely. Positive 5 and positive 5. Does it give me the right middle? Yeah. 5M, 5M, 10M. But we did see some that look like perfect squares, but the middle wasn't the correct term and you had to use other factors. Like if this middle term was 26, we'd be doing 25 and 1. Anytime you have something times itself, you need to write it as the quantity squared. Okay? Now, look at 14. Just a trinomial. 16 and 100 are perfect squares, but we saw this before. What about the GCF? If you don't take out the GCF now, it will factor 4u and a 10v in both things. 4u plus 10v and 4u plus 10v. The problem is the 4 and the 10 have common factors, don't they? So what would be the GCF for these three terms? I was thinking 16, but that doesn't work in 100. And 8 doesn't work in 100, so just a 4. But I would have tried the 16 first. All right, so just a 4 comes out. You're left with 4u squared plus 20uv plus 25v squared. Now, do you see that I still have these perfect squares? So again, it might not stand out to you because it looks like just a trinomial, but I've always said try the double factor, that double digit factor first, and make sure it works. So 2u times 2u, a positive 5v and a positive 5v. But rather than jumping to conclusions, you want to make sure that you get 20. So we multiply, we get a 10uv and another 10uv. It does work. So final answer, 4 times the quantity, 2u plus 5v squared. But again, we've seen some that don't work, so you definitely want to write this out and try it first. All right, so we're going to go back to numbers 3 and 4. And so this is where you want to pause the video and go ahead and try these two problems. And the hint is that it factors in more than one step. So I'm looking at this and I see a trinomial. I see there's a 1 out front. So it's definitely the easier factoring, but it's going to keep going. Number 4 has no GCF, but it has 4 terms. So I'm going to jump in and factor by grouping. So looking at this first one, I jumped in. Now, anytime I have it has to be an even power, and I have to break it up evenly. So, when we multiply bases, we add the power. So this could be x to the 6, and that could be x to the 2nd, but it won't work out to give me that common middle term. So that's why we're taking this and splitting it always evenly. So when I do my outside and inside, they're both x to the 4th. There are factors of 25 that add up to negative 26. It's a negative 25 and a negative 1. I had to think about that for a second because I was messing up my signs. So this is how the original factoring goes. Negative 1 times negative 25 is 25. They add up to the negative 26x to the 4th. But do you see those difference of squares? I know their powers of 4, but can't they split up? So this is a difference, x2, x2, 5, and negative 5. So this is going to break up to be x squared plus 5 and x squared minus 5. Now, same thing with this. A lot of people forget about 1, but negative 1 times positive 1. So this guy breaks down x squared plus 1, x squared minus 1. So why did I know to look for that? Well, because this is what I do. But I also knew to look for it because every time I factor, I look and see if there was a GCF I missed or if I had a higher power. And because I have 2 terms and I had a difference, I had that difference of squares both times. Now, these all have a power of 2. Well, first of all, that's not a difference, so I don't have to worry about it. There's nothing else that factors. This is a difference, but is 5 a perfect square? Now, there's no factors of negative 5 that add up to 0. This is not a difference. There's no factors of 1 that add up to 0. Don't I have 0x in the middle? But this is another difference of squares. Do you see it? All right, so we would have x squared plus 5, the x squared minus 5, the same x squared plus 1, but this is what I'm factoring. X plus 1, x minus 1. Now I've double checked everything with higher powers. Now I've got it factored completely. Okay, so looking at number 4, no GCF, okay? So I'm going to come in and I'm going to group. Remember, we squeeze that minus sign in and put a plus sign because we don't want to multiply there. The first set, I can take out x to the 4th. I'm left with x squared plus 3. The second set, I'm going to take out a negative 25 to change it to a positive x squared and a positive 3. So looking at these two pieces, they have in common x squared plus 3. Take that out. I'm left with x to the 4th minus 25, which is what we had over here. So it's not a big difference now that we've seen it, but this will not factor because it's a positive 3. There's no factors of 3 that add up to 0, so that guy is going to stay. But this is a difference of squares, so x squared plus 5, x squared minus 5. And it doesn't factor further because they're not difference of squares. All right, so what you're now going to work on is this back mix. All right, so this is what your focus is. Now we have all these problems that we're practicing, and so when I look at them, I see 3 terms. I'm going to look for a GCF, and there's not one, so I'm either going to be doing trial and error or busting B, whichever method you like. This definitely has a GCF of 3, so I would take that out, and then it's easier factoring. If I have 2 terms, again, I'm looking for a GCF, and is it a difference of squares, or is it just a GCF? If I have 4 terms, always looking for a GCF, and then factor by grouping. So use your skills. Look for those perfect squares.